Today I'm going to talk about two difficult subjects, not technically difficult, but just difficult. One is the environmental Kuznets curve, which I think is a mistake, and the second, and that's why it's difficult, and the second is the whole issue of environmental justice. If you're sensitive to these sort of things, then be warned, right? Because I'm going to reveal some things that may trigger you and you may not like it. I definitely do not like them. This is where we are. We have 1 week to go after this. So we've done all the basic theory. And now we're going to look at two applications, right? Or three applications. Essentially, two this week and one next week. I'm going to start by talking about the environmental Kuznets curve. The environmental Kuznets curve is named after Simon Kuznets, who, this must have been in the 1930s, argued that as countries grow richer, they move from left to right on the horizontal axis, they first become less egalitarian, less equal in income, but then as they grow richer still, they grow more equal again. The mechanism is very simple. In subsistence societies, essentially there's nothing there, right? Everybody is at a very basic level, because there's essentially no surplus to go around. Then as an as an economy industrializes, there are resources to be gained by certain individuals, and then as we move to a more advanced society, the income distribution becomes more equal again. That is what Kuznets thought. It's probably not true. If you think of some of the ancient societies, they were actually very, very, very unequal, even though they were they were at a very low level generally, but there were some individuals who were extremely rich. And of course now we're here and we're sort of like seeing the accumulation of wealth in a very narrow elite again. So Kuznets was probably wrong about this, but at the time that he wrote it, there was some empirical evidence to support it. And this became known as the Kuznets curve, right? Relatively okay when you're poor, worse when you sort of in the middle income, but it's getting better when you grow richer again. And then people wondered, perhaps this holds for the environment as well, right? So very poor societies, pre-industrial societies, put very little pressure on the economy. Then pressure grows as the economy industrializes, but as we move to a service economy, the environmental pressure, the pressure on the environment, emissions, and so on and so forth, fall again. That is why, but it is essentially the same shape of curve, and even though Kuznets had nothing to do with this, he was long dead by the time this was proposed, it is known as the environmental Kuznets curve. Now, why do we talk about this? Essentially because these two gentlemen, Gene Grossman and Alan Kruger, in 1991 wrote a paper about this that is probably the most cited paper in environmental economics. You see that the original paper has got to more than 12,000 citations. It took them a while to publish this, and the published version from 1995 also got more than 12,000 citations. And these two papers are the most cited papers in environmental economics. Alan Kruger used to joke about this, that even though he's a labor economist, his most cited paper is in environmental economics, and he used to scold environmental economists like myself about this. It's a bit mysterious why Alan got into this game. The other guy, Gene Grossman, it's actually, these are his second and third most cited papers. He is a trade economist, and you can sort of like see from the very first version of this paper that really this was about the environmental implications of NAFTA, right, which was then brand new. And somebody had asked him what would NAFTA imply for the environment, and he was looking at that, and apparently he picked up Alan, who was a junior lecturer at that time at Princeton. They were together, and that probably explains why they got into this. And it just started a cottage industry of people saying, well, I can do this too, right? And people have been doing this. Now, what did they actually do in this very first paper on the environmental Kuznets curve? Essentially, they started by just plotting environmental pollution against income. So in all these graphs, we have GDP per capita on the horizontal axis, and we have various indicators of environmental emissions on the vertical axis. It's easier to read here than here, that's why I'm moving back and forth. So this is sulfur emitted in cities. This is heavy particles. At that time we were not able to measure PM10 even, I think, let alone PM2.5. So this is heavier particles, and this is smoke. And what you see is that for smoke, though there's only 6 observations, sorry, there seems to be something like an environmental Kuznets curve, right? It starts low, it goes up, and then it goes down. Sulfur, if you throw away these observations, environmental Kuznets curve appears. For heavy particles, perhaps we see the lower end, the right-hand side of the environmental Kuznets curve, right? It's just coming down. This is dissolved oxygen in rivers. I'm getting entangled in my cord. Nothing like an environmental Kuznets curve for biological oxygen demand. Well, perhaps. This nitrates in rivers, this is chemical oxygen demand in rivers. Perhaps, right? Perhaps we're seeing something like this. This is fecal coliform, shit essentially. Steady, but it does seem to be coming down. This is total coliform in rivers, and again there's no environmental Kuznets curve to be seen here. Lead, cadmium, these are the heavy metals, arsenic, mercury, nickel, these are heavy metals, these are just metals, right? No, they all call them heavy metals. The very first paper on the environmental Kuznets curve is entirely unconvincing that there is such a thing there as an environmental Kuznets curve, right? They did run a whole bunch of regressions, and essentially what they found then, you essentially regress the emissions to the environment on income and income squared, and then you calculate where is the top of the quadratic equation. And you see that displayed here. Completely different numbers for different substances. For cadmium, it's 11,600, the turning point. For dissolved oxygen, it's 2,700, so that's an order of magnitude smaller. And then they have some other characteristics. It doesn't seem to be at all convincing, right? The graph shows you there's not necessarily a parabolic curve or anything that looks like a parabolic curve. The regressions are all over the place. Often things turn out to be insignificant, and so on and so forth. Despite this very weak initial evidence, thousands of people thought, I can do this too, and I can do it better. And what we have seen since is this cottage industry of people estimating the environmental Kuznets curve with different indicators of environmental quality, right? I showed you the things that they looked at, but of course we constantly improve our measurement of the environment. We can now measure things that we used not to be able to measure. Back in 1991, we measure it in different places, we measure it with higher precision, and so on and so forth. So people have been doing this. Their analysis was primarily for the United States, but people have been looking at different countries, different sectors, ever expanding. Now, of course, as time progresses, we measure more and more and more and more. They necessarily stopped in the early 1990s, right? But now we can go up to 2023, sometimes 2024. People have also been trying to push this into the past, right? In some cases back to 1850, in some cases a little bit further back even. And resolution has increased, so we can do this on a monthly timescale rather than an annual timescale, sometimes on a daily timescale. Of course, you can throw in additional explanatory variables. You can try, instead of a quadratic relationship, a cubic relationship or a quartic relationship. You can do it with log transformations. You can do it with arcsine transformations. You can think of a million things to do, and that is what people have been doing. And then, of course, you can do this with OLS. You can do this with fixed effects panels, with random effects panels. You can do this with logit. You can do this with Poisson estimators, and so on and so forth. And that sort of explains why this literature just exploded, right? It just exploded. But they did not find anything different from what Grossman and Kruger found. And in 2004, David Stern, who you see here, published this paper, The Rise and Fall of the Environmental Kuznets Curve, and a year later, Macio Galeotti, that's this guy here, published this paper, Desperately Seeking Environmental Kuznets. Macio is a big fan of Madonna, and this was a movie in which he started the moment Madonna at one time was as big as Taylor Swift is now. And essentially these two papers, published now 20 years ago, found that there's essentially no empirical evidence for the environmental Kuznets curve. And also explained why, and I'll get back to the why. I'll get to the why on the next slide. But that did not stop people looking for this, right? And the reason is probably that you sort of like plug into a large literature, and then it's relatively easy. You just follow somebody's example. And this is the sort of thing that sort of like less ambitious, lower skilled researchers just keep doing and doing and doing and doing and doing and doing. And most of these papers are just very boring, but as I said, it is the most important thing in the published literature in environmental economics for reasons that are completely and utterly beyond me. Because the ambiguity of the results is utterly unsurprising, right? So what happens if an economy grows? What happens to the environment? Well, first thing that happens, if an economy grows bigger, it is bigger, right? So that's a scale effect. So if there's more people around with more money to spend, that is, you have a bigger economy, you're gonna emit more, right? Simply by the fact that there is more stuff to go around. You're gonna consume more, right? You're gonna produce more. So simply, a bigger economy must have a larger environmental imprint. There's just no two ways around it, right? So this is simple, right? But then there's other things that are going on if an economy grows. The first is that the composition of economic activity changes. So typically, very underdeveloped economies are dominated by agriculture. And that means that there's no heavy industry out there, right? And electricity use is very, very low. So you don't have any of the emissions associated with heavy industry or with power generation. So if you then move from agriculture to manufacturing, yes, environmental pressure increases. But then after a while we sort of get bored with just making things and using things, and we actually move to a more service-based economy. And the UK is of course a good example. Most people in the UK work in retail, they work in hospitality, they work in financial services, that is, they sit in offices, they don't operate machinery. And people who work in services typically put less pressure on the environment than people who work in manufacturing, right? And if the economy shifts to services, then you see a reduction in environmental pressure. Definitely the sort of heavy, the bad chemicals and stuff. So here indeed you see an environmental Kuznets curve emerging, and it just depends on where you are in your development, how quickly this goes and how it goes exactly. But it's not as simple as this, right? Because as we get better at manufacturing, we also get better at making fertilizers, right? Which are used in agriculture. As technology progresses, we also put more and more. Agriculture is also getting more and more mechanized, more and more chemicals, more and more different chemicals are being used in agriculture. In the opening lecture, I talked about intensive agriculture and the antibiotics that are used. I talked about eutrophication and so on and so forth. That comes out of agriculture. It comes out of modern agriculture. It doesn't come out of traditional agriculture. And of course, what we have at the moment is the rise of artificial intelligence and the very heavy electricity consumption, electricity use, I should say, of data centers, right? That is by far the fastest growth in electricity demand at the moment. And this is something of the service economy, right? All those large language models essentially work in the service economy, and as a result, we see the demand for electricity, and therefore the generation of electricity and all the CO2 that comes out of it rise very rapidly. So what is going on here is actually not a simple up and then down, right? It's much, much more complicated than that. Technology also tends to improve, tends to progress as we develop, or maybe it's the other way around, right? This is one of the main drivers, not maybe, this is one of the main drivers of economic development, right? And typically, if you compare like with like, things are getting better, right? Newer mobile phones are more energy efficient than older mobile phones. Newer cars are more energy efficient than older cars, and so on and so forth. Newer buildings tend to be better built than older buildings. So that is an improvement in efficiency, right? And that puts less pressure on the environment. So we're on the downward slope of the environmental curve. But also we're constantly inventing new things. And that means that we create new environmental problems. If you take solar panels, for instance, they are full of nasty chemicals, right? That is the way these things are made. And that is no problem at the moment, because most solar panels are relatively new and they're safely installed on people's roofs. But in the foreseeable future, they will reach the end of their economic or their technical lifetime, and they will have to be taken down. And that is essentially chemical waste, right? And that will introduce all sorts of new chemicals into the waste stream that has never been in the waste stream, right? And we will need to deal with that, right? So technological progress also creates new environmental problems. Similarly for batteries, right? Batteries are of course older, and we have more experience in dealing with old batteries, but of course the batteries that we're making now are very different than the batteries that we used to have, right? 20, 30, 40 years ago. So we're constantly introducing new environmental problems, right? Not ones that are unmanageable, but definitely new. So again, here we have a very ambiguous effect, right? Typically, richer people demand a cleaner environment. That can be misinterpreted. It's not so much that poorer people don't care about the environment. It is that richer people are able to act on their desire for a clean environment, right? Because they're not busy making sure that the kids make it through the night. They actually have the luxury to care about these things and spend money and time on improving the environment. So this is actually a fairly unambiguous effect. The richer you are, the cleaner, the more you are willing to pay to clean up the environment. Let's put it that way. Another important component of economic growth is changes in the way governments are run. Typically, what we see, but there are important exceptions here, is that as economies grow, governments get better at doing things, at providing public goods. And again, as with technology, it may actually be that the causality is the other way around. As governments get better at providing public goods, the economy grows, right? And of course, environmental care is about providing public goods. It is about preventing externalities, right? Or internalizing externalities. So in that sense, a richer country is just better at environmental care. But richer economies also tend to have more democratic governments, and that just slows down the machinery of government, essentially. Because you need to talk about everything before you make a decision, right? More democratic governments are actually very slow at making decisions compared to more autocratic governments. More democratic governments tend to care more about the environment because their people care about these things. But it just clogs up decision making, right? So again, the relationship with development is actually just from first principles. You can't say it's going to go up and then down, right? That just not what you would expect, right? So now that you know this, you should be absolutely not surprised that the empirical literature finds very little robust support for the environmental Kuznets curve. There is perhaps a little bit, if we're looking at local pollutants that are directly harmful to human health, you can say, well, this is a typical pattern. If we look through all those 20,000 papers or so that are there, you would indeed find something like an environmental Kuznets curve, but not a consistent one. Not consistent in the sense that you would always find the same turning point. You would actually find it's something that looks like a parabola, but its height, its spread, where is its turning point, and so on and so forth, is very, very different between different contaminants, between different environmental pollutants, between different countries, between different periods, right? Even if you sort of like look at the same chemical for different groups of countries, you would find that they turn at different points depending on their states of development and so on and so forth. You can sort of like sometimes see it in the data, but it will not allow you to predict anything because there is no statistical regularities in the empirical evidence where you sort of like say we've observed this for half of the countries in Africa and now we know what's going to happen with the other half of the countries in Africa. No, that just won't. That is just not the case, right? For global environmental problems, there is no environmental Kuznets curve in sight whatsoever. If you focus on CO2, carbon dioxide, if you focus on biodiversity loss, there's no such thing as an environmental Kuznets curve in the literature at all. It's just not there, right? And that is if we keep it simple, right? if we introduce international trade into the story, it actually becomes much more complicated still, right? Because previously what I said about these 5 mechanisms assume the closed economy, right? Now, if you open up the economy to international trade and investment, things get more complicated still. What we're looking at here are CO2 emissions. For the UK, China, the United States, and India, in blue, you're looking at the emissions of carbon dioxide that come out of economic activity in the country. So, residential use, transport, and production activities within the borders of the United Kingdom, right? That is one way of measuring emissions, and it's the easy way of measuring emissions. The alternative is to assign the emissions not to the place where production took place, but to the country where the consumption took place, right? So the UK hardly makes any steel anymore. We import most of our steel from other countries. Steel is very energy intensive. A lot of CO2 comes out of steel production, and you could assign the CO2 that comes out of the steel that we use to the UK rather than to the countries where the steel was made, right? And then we move from the blue curve to the red curve. And what you see in the UK, there is a fairly substantial gap between the two. In the United States, same qualitative pattern, but the United States is a much bigger and much more closed economy, so the absolute effect is different. Why is this so? Because a lot of our heavy chemicals, a lot of the products of heavy industry are imported from places like China, and in China you see the opposite effect, right, where the territorial emissions are higher than the consumption emissions based on production versus emissions based on consumption. That is, a lot of the emissions that come out of China are not to serve the Chinese market, but they are there to serve markets elsewhere, right? It should not come as any surprise to you. India is actually the same. India is, of course, much more service export oriented than products export oriented, but still there's a lot of export coming out of India, right? And you see the same qualitative effect there. Quantitatively, it's a bit smaller, a good bit smaller, because the scale is also different of the two vertical axes, right? And this is an important thing to keep in mind. If you then stick this into a regression, and that is what is going on in this particular table. So here we have your standard environmental Kuznets curve, right? Again, the variable of interest is biological oxygen demand, that I explained last week. And they run the regression on income and income squared, right? And you see an environmental Kuznets curve there, right? You have a negative linear effect and a positive quadratic effect. This is not an environmental Kuznets curve, right? So it's negative at first and positive later, because at low incomes the linear dominates, at high incomes the quadratic dominates. So the curve that we see here is this, right? It's an inverse parabola, not a parabola. If you want a parabola, then what you need is that your linear term is positive, going up for low levels, and your quadratic term is negative. Then you get this shape. If it's the other way around, you get this shape, right? So they did not find an environmental Kuznets curve here. They found the opposite of the environmental Kuznets curve here. So you may think, yay, we found at least significant numbers, right? Then they started controlling for other things, and the effect did not disappear but completely changed. And then here they stuck in indicators of the trade intensity. And what you see is that the effect of income just becomes insignificant, right? So as soon as you correct this for international trade, and this is mostly stuff that comes out of agriculture and some chemical industry, it just completely changes. Then they re-estimated the model, they tried a different specification, and income popped up again, trade remained significant, but the numbers are completely different, right? It changed from minus 67 to minus 160, and from plus 0014 to plus 0019. So the relationship completely changed numerically, right? And yeah, it's important to correct for this, and your conclusions just drastically change. What did I do? And the same is shown in these particular graphs. What we have here for cities in China, in blue for cities in the UK, in orange for cities in the US, in grey are emissions of, I'm pretty sure, carbon dioxide, it doesn't say, as a function of per capita income. And you see no environmental Kuznets curve here, right? Then my thing is very, 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 very sensitive. These are production emissions. This is the same, but not now what is actually produced in these cities, but what is consumed in these cities. And you see that there's a different relationship there. Still no environmental Kuznets curve. Here we plot these against these, and you see, well, it's roughly a linear relationship, but not quite. Particularly UK cities seem to be behaving differently. Oh wait, no, that's not what I should say. So the straight line that you see is not the best fit, it's just a 45-degree line, right? So what you see here is that UK cities just consume much more than they produce, right? Or their consumption emissions are much higher than their production emissions. Same is true for cities in the United States, whereas cities in China are sort of, some of them are clearly export oriented, others are more like modern cities in the UK and the US. That is what I should say about this graph. And it's only when you plot the difference between consumption and production emissions as a function of income that you see something like an environmental Kuznets curve appear, right? So really what you see here is that in the early stages of production, in the early stages of economic development, you're very much export oriented, and then in later stages you become more and more import oriented, and that means that your consumption emissions become much, much larger than your production emissions, where in the early stages of development your production emissions are larger than your consumption emissions. And here we see a very clear shape that looks like an environmental Kuznets curve, except that it's not about emissions, right? It's about the relationship, it's about international trade. Empirically, it's just all over the place, right? It's just all over the place. International trade makes it more complicated. Of course, politicians really like the idea of offshoring environmental problems, because then it goes to people that don't vote for them, right? I showed you the example of CO2 emissions, energy intensive industry disappearing to China, right? Which is great, it's now their problem. Not quite true, because for CO2 it doesn't matter where it comes from. For other pollutants, nitrogen, sulfates, eutrophication, the nitrogens and the phosphates, as well as particulate matter, it does matter where it's produced, right? So essentially we're exporting our environmental problems to other countries. And sometimes this is literally the case. There's also still a lot of trade in waste products, where chemical waste that we don't quite know how to process in the UK, or we are not quite willing to pay for its processing, we put on a boat and ship it to Nigeria and dump it in a river there, right? There's still a lot of that sort of stuff going on. So we're exporting our environmental problems. And that is, of course, very tempting if you're a politician, right? Instead of having a chemical waste problem in your backyard, you have it in a country that is far, far away. It's, of course, it's actually illegal to do so, but it's also entirely immoral to do this, right? And then once you start accounting for the ever more complicated value chains, you start looking at assembling, transport, and then things get very, 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 very hairy very rapidly. Right? Two more short chapters to go. You can also look at the environmental Kuznets curve over time. So far what I've been showing is actually cross sections, sometimes panel between countries, but you could also do it over time, and there's an increasing number of studies that do so. What we're looking at here is CO2 emissions in the United States, not across the different states or the different counties in the US, but over time. In green, you're looking at the CO2 intensity, that is how much CO2 you emit per dollar value added. And in red, you're looking at CO2 per capita, that is how much CO2 you emit over the number of people in the country. And that is plotted against per capita income, right? So really we start the analysis in around 1850 and run it all the way to the year 2000, right? So what you see here is something like time and economic growth, because this is average per capita income. And then you see the green pattern looks like a Kuznets curve, right? When the US was very poor, it emitted not a lot of CO2 per dollar value added. Then it rapidly rose, and then it came down, and it's ever so slightly coming down, right? This is CO2 emissions per capita. You see a rapid rise and then essentially a stabilization, right? Of course, the population of the United States keeps growing, and its absolute emissions keep growing, right? But essentially for every person you add the same amount of CO2. It's not that CO2 per capita is growing, or at least until the year 2000. The explanation for this green pattern lies here. In brown, you're looking at the consumption, or the use, consumption, let's call it, of coal, which rose rapidly and then stabilized because coal is expensive and silly, and you can't do much with it apart from burning it to make electricity. Then on top of that, we add oil, and you sort of like see that from the 1930s onwards, you see coal is essentially stable and oil takes off. And then from the 1950s onwards, we add in red gas, and you see that from that point on, natural gas takes off. This is low in CO2 emissions per unit of energy. This is higher still, right? And it's this shift away from coal, first towards oil and then towards gas, that explains why this green curve is coming down, right? And of course also we use energy more and more efficiently. So you could draw pictures like this. You can do it for an increasing number of countries. This was one of the first studies. done over such a long period. Now, what are the policy implications? You could, of course, just stop here at this point and say the empirical evidence is so chaotic, so all over the place, there are no policy implications. And I wish I could do that. As I said, I'm not a fan of the environmental Kuznets curve because it's just theoretically ambiguous, and therefore it's no surprise that the empirical evidence is all over the place, and the world would have been a better place had Grossman and Kruger never written that paper, right? Although somebody else may have been tempted, right? But there's also a whole bunch of people who actually believe in the environmental Kuznets curve and draw the wrong policy conclusion. And the wrong policy conclusion is that if we just grow rich, everything will be fine. That economic growth in itself will solve all environmental problems. And that is a very persistent thought in some people who don't know better or who do not want to know better, right? And going back to Alan Kruger, right? So Alan should have won the Nobel Prize, right? Because he is one of the founders, one of the people who were at the beginning of what is now known as the credibility revolution, where in economics we moved away from measuring correlations between variables, associations, as they're now known, to trying to measure causal relationships between two variables, right? Alan was at the very start of that. And it was Alan Kruger's paper with David Card that started this, right? And Card, of course, won the Nobel Prize for this, but Alan was no longer with us when that happened, but he would have shared. So going back to what I was saying, so Alan used to joke towards environmental economists like myself that my paper in environmental economics is much more cited than your paper, right? And you are a specialist in this. But of course, right back at you, Alan, even though you are sort of one of the founders of causal inference in economics, your most cited paper is an association rather than a causal relationship, right? And I think this is best illustrated with cycling, right? So what you're looking at here is a map of cycle paths in Europe. And this map should not surprise you, right? The Netherlands, Flanders, parts of northern Germany, don't go all the way up to Denmark, are just completely red, right? There's just cycle paths everywhere, right? Compare that intensity to England, and it's just pathetic, right? In this country, the number of cycle paths, the number of facilities, dedicated facilities for cyclists. France, of course, is even more pathetic. And this is a common misconception that people have, that people in the Netherlands are sort of like genetically disposed to cycling, and it's always been this way, which is just not true, right? This is just not true. What you're looking at here are two streets in Amsterdam. The Eerste van der Helstraat and the Gerard Douwstraat. Doesn't mean anything to you. This is what streets looked like in the 1950s in Amsterdam. Just streets that people were walking, where people were cycling even. Here's a bike. There was actually a horse-drawn carriage in the 1950s still on the streets of Amsterdam. Then if you look at the 1970s, these are the same two streets, almost the same viewpoint, right? I mean, the building has slightly shifted. And you see the streets just overrun with cars, right? And then if you took the same picture again in 2020, you go back to the original situation, except that it's now in color, and you see cycling, you see walking, and the cars have largely disappeared, right? So we see here an environmental Kuznets curve, right? Low pressure on the environment, very few cars, lots of pressure on the environment. Netherlands grew richer in this period, and then it grows richer still and the cars disappear. So this suggests an environmental Kuznets curve. But the question is, of course, why did this happen? What made this happen? Because if any of you have been to London, and many of you have, London looks more like this, right? Except that we take color pictures of London rather than black and white pictures. But London is still overrun with cars, as are many cities in the UK, right? Why did this happen in Amsterdam and all over the Netherlands, and now in Paris, a little bit earlier in cities like Munich and Hamburg and large parts of Germany? Why not in the UK, right? Why not in the UK? I will postpone, but why did this happen in the Netherlands, right? Why did a country that was completely overrun by cars decide to change course, right? And the answer is actually complicated, but the starting point is this graph here. This is the number, the annual number of fatal traffic accidents. And you see that in the 1950s there were few because there were not that many cars. Then it more than tripled until 1972, and then it gradually came down. This is by mode of transport. This is the same graph by age of victim, right? And that is essentially, this was the turning point, obviously. And the turning point was that the son of an influential journalist got killed in a traffic accident, right? And instead of just mourning, he actually decided to protest, right? And he started this movement. For those of you who don't understand or read Dutch, this means stop child murder, right? You probably figured it out. Moord is murder, kinder is children, right? It's the same word, and stop is stop, right? And that was extremely influential, right? Because it was not just this one kid that got killed, there were actually a good many that were killed in traffic, right? And the Dutch just said, stop it, right? So this is a picture of what Amsterdam looked like at that time, really unpleasant environment. And then there were just protests, right? This is the Rijksmuseum that you may have been to, Museumplein, Museum Square, right, where there was a big protest and people pretended, so it was essentially not a sit-in but a lie-in with your bike. These people all pretended to be dead. There were actually cars being harassed, right? It's pretty scary if you were in this car, and there were just streets being blocked, right? This was a very vocal, occasionally violent protest against cars. And there was also a change in sort of the public perception. You know Rutger Hauer from Blade Runner, right? Tears in the Rain. Same guy. That was when he was old. Before he moved to Hollywood, he was actually the most popular actor in the Netherlands. All the girls wanted to be with him. All the boys wanted to be him, right? And here in this 1973 movie, it's Monique van der Ven, who you not quite as famous, but family of very similar stature, right? All the boys wanted to be with her, all the girls wanted to be her. And in this particular scene of a very influential, very popular movie, they made cycling cool, right? Essentially, before this time, young guys wanted to have a car, right? Because cars are cool. But then these two got on a bike and cycling became cool, right? And that was an important shift in the mindset. Now, some of you may have seen this movie for other purposes, right? And this makes, small example, makes clear that the environment just doesn't improve itself, right? What is needed is a desire to improve the environment, right? You need policy intervention. So what happened after these things, right? After these protests, after this movie, all these things, actually two things happened. One is that politics changed in the Netherlands, from moving from a more patrician type of democracy, right, where you elect people who then tell you what to do, right, to a more direct democracy. So local government in particular became much more responsive to what the people actually wanted, many more focus groups and discussions and so on and so forth, much more open style of government. And they started building cycling paths, right? They started putting the infrastructure that is needed to make cycling safer. They changed liability. If you're in an accident, it used to be that both parties were equally likely to be found guilty if there was an accident. And that's still the case in the United Kingdom, right? If you get on your bike and you get into a collision with a car, they may say it's your fault and they may say it's the car's fault. In the Netherlands, the presumption is that it's the driver, it's the car who is at fault, right? And you have to work really hard to show that you're not at fault, right? That meant that legal liability changed, that meant that insurance changed, and so on and so forth. And all these things gradually made cycling safer for people, which of course then means that more people took up cycling, which meant that there was more of a demand for safer cycling infrastructure, and so on and so forth, right? So that was the Netherlands in the 80s, right? Similar things happened 10 years later in northern Germany, 20 years later in southern Germany, and of course nowadays it's happening in Paris, right? I have been a regular visitor to Paris for a number of decades, and it's absolutely astounding what is happening in Paris, right? You see sort of like streets that used to be just car parks now turning into areas where people actually can be, right? Outside of the car. The reason that this is not happening in the UK is because the same transformation simply haven't happened, right? There's never been a big protest movement against cars in this country. Sort of the shift towards more local government is sort of like very haphazard. And at the moment, if you talk to local politicians in England about cycling, they think it is a mode of sport, right? You do cycling for sport, you don't cycle for transport. The idea that you would get on a bike to get to school is alien to planners in the United Kingdom. Part of the reason is that they simply have not made this transformation that other countries are making. And part of the reason is also because the lobbyists for cycling in the UK are also dominated by people who see cycling as a sport rather than a means of getting from A to B. The Cycling Association of Great Britain, I should say, is still against dedicated cycling lanes because they somehow got it into their heads that if we build dedicated cycling lanes, then bikes are no longer allowed on the regular roads, and they want to maintain their freedom. So it's actually the cycling lobbyists who are lobbying against bike lanes in the United Kingdom, right? Or in Great Britain, I should say. And that is why the UK is decades behind Europe with regard to cycling infrastructure, right? But the bottom line conclusion here is that the environmental Kuznets curve is an association, right? The environment doesn't get better because we get richer. The environment gets better because people are fed up with a bad environment and take action to improve it, right? That is why pressure on the environment falls, not because we grow richer. There is no causal relationship here. The relationship is with people taking action. For the break, I talked about patterns of environmental pressure over time, different levels of development and across space, between countries and between cities, right? So if these patterns can be found, then it stands to reason that you would see the same patterns across the income distribution. There hasn't been a lot of research about this, but there is some. Here is one example by Matt Kahn, who you see there at the bottom. We have per capita income on the horizontal axis, and this is CO2 emissions from driving. And you see an inverse environmental Kuznets curve, right? So poor people, this is the United States, tend to have very high emissions, and that is because they tend to live far from their work, and they tend to drive very old and inefficient cars, right? This is the United States. There's very little public transport. Then as people grow richer, they tend to move closer to work. Emissions are coming down, and they tend to drive newer, more efficient cars. And then as people get richer still, they get into the bigger cars and the heavier cars, and they tend to travel a lot more, mainly for leisure, right? As well as for, they fly more, right? And that is why you see this particular pattern, right? But the bottom line here is that it's not just between countries, not just between cities, but also between income groups. Similar story here. This is for Ireland. And instead of looking at carbon dioxide, we're looking at carbon monoxide. In dark blue, you're looking at the direct emissions, the stuff that you do in your home. We're talking about carbon monoxide, so this is cooking, this is mowing the lawn, that sort of stuff. That is where carbon monoxide comes from. Indirect is from the stuff that you buy, right? And that, of course, comes on top. And we see sort of a similar pattern in, if you're looking at income groups, that is what you see here. This is just bad equipment, essentially, right? And then as people get richer, they get better equipment and therefore emit less carbon monoxide, newer and better equipment. But of course, richer people buy more, and therefore it increases like this. Here we're looking at household size, and what you're looking at here are economies of scale in household production. If you're heating your home, and if you burn oil or gas or coal to heat your home, you're producing carbon monoxide. If you heat your home for one person, you need about as much energy as if you heat your home, the same size home, if there's two people living there, right? Actually a little bit less, because your body also radiates heat. So that explains why larger households are simply more energy efficient. So if you want to save the environment, go live with someone, right, rather than on your own. Here we're looking at the structure of the household. Very similar story. This is perhaps the more interesting one. These are the number of disabled people in the household. And what you see is a bit of a mixed pattern here. If you have more disabled people in the household, then you tend to spend more time at home because you're less mobile. Also, you tend to use more machinery and heat the place more, and that is why you see direct emissions go up until you go to a household where basically everybody is disabled. And this is simply a poverty effect, right? these people, if you have a severely disabled household, then essentially there's no money to go around, right? So that is why it comes down again. And that also explains why the indirect emissions are coming down, right? So there's also very clear patterns across different types of people, different types of households. I did not talk about rural and urban. These are essentially, rural is much higher. This is because lawnmowers, essentially, we're talking about carbon monoxide, right? And you can also see this over time and over age groups. This is the age in 2015. So the further you, these are people who were born in 2015 and then people who were born in 1995 and back. So you're essentially traveling through time. The thing we're looking at are childhood blood levels of lead. You can measure that because it sort of like gets stored in your system, and we can now are able to determine how much lead you were exposed to when you were a child, right? Even people who are fairly old, realize it sort of like permanently changes. Is that how they did it? I think that's what they did. And you see sort of like the very clear exposure of the people who were sort of in the gasoline age, right? So very old people, they sort of grew up when there weren't that many cars on the road. And then you sort of like see the increase in the number of cars on the road, and therefore also the amount of lead in gasoline, and therefore the amount of lead in the environment, right? And then we decided to take out urban air pollution, and in order to do so you need to put a catalytic converter in your car, and lead in gasoline screws up your catalytic converter, so we moved to unleaded gasoline, not because we cared about lead, but we cared about urban air pollution, but we took the lead out, and then you see the lead disappear. Now, why is this important, and why did the y-axis publish this? Exposure to lead when you're very young essentially slows down your cognitive development. Essentially, you become dumber. If you plot this against voting patterns, you can sort of like see MAGA here, right? This may have been a direct consequence of the amount of lead that we put in the environment. Same relationship holds for the people who vote for Reform UK and that sort of parties in the UK. So pressure on the environment is different for different socioeconomic groups, right? But concerns about environmental justice do not stop here. And this is essentially what environmental justice is about, that different people are disproportionately affected by environmental problems. Because there is much more structure to this. This is a paper that Jonathan Colmer and colleagues published now 5 years ago in Science. We're back in the United States, 1981 to 2016, and this is the concentration of PM2.5. And what you see is that it's been steadily falling over time, and you think this is a good thing, right? This is the geographic pattern of this. It's pretty faint. In blue, you see a decrease in PM2.5. In yellow and red, you see an increase, at least in the relative ranking of PM2.5. And this is the history of the economic geography in the United States, right? We sort of like see the Rust Belt slowly declining economically, and we see the southern states, the Sun Belt, increasing. Ruben?
What is PM2.5?
PM2.5 are very tiny particles, so tiny that their diameter is less than 2.5 micrometers. This is of concern because it's not so much the chemical reaction of these things, it can be essentially any substance. Because they're so tiny, they can penetrate anything And PM2.5 can cause lung cancer. It's also known to essentially reduce your cognition again, make people more aggressive, make people essentially make more mistakes. The reason for this, the reason that we're worried about PM2.5 is that they're so tiny that they can fly through walls, right? So they're also indoors, and they're so tiny that they can cross the blood-brain barrier. So they get into your head as well, and your brain mistakes them for neurons firing, and you do all sorts of weird things. So PM2.5 is something to be concerned about, right? Now, this is the history of economic geography in the United States, right? The shift from north to south. Now, if you also know the racial geography of the United States, this graph is no surprise. What we're looking at here is the exposure to 2.5 in African Americans versus the whites, right? The Hispanics are in a separate grouping, but they did not include them in this particular graph. And what you see is that the exposure of darker skinned people to PM2.5 is greater than the exposure of lighter skinned people, right? Complicated story here. This is essentially the same graph. This graph is reproduced here. The difference between the two is the gap, right? Here it is controlling for, I think, race only. And this is controlling for all sorts of characteristics of the tract, that is relative income and so on and so forth, whether it's urban, whether it's rural, metro, and so on and so forth. Because black people tend to live in different places than white people, right? And if you control for all that, you see that the gap does not disappear, right? So here we see the two lines. This is the difference between the two lines. This is the difference between the two lines if you control for education, occupation, income, and so on and so forth, right? You see that the gap does not disappear. And here, these two lines are plotted next to each other, and what you see is that they're virtually identical, right? So the difference between darker skinned and lighter skinned people that you see here is not because darker skinned people tend to be poorer, less educated, and so on and so forth. It tends to be their skin color, right? And that is what is going on here. So this is PM2.5 for the whole of the United States. This is Houston. In the top, or the greater Houston area, in the top you're looking at where are the waste facilities located in the city. That's in this band here. And at the bottom map you're looking at where are minorities located in the city. And you see that there's an uncomfortably close correlation between the two, right? Let's move to Richmond. 8 maps. This is the temperature in the city, right? And red means hot. We're in, oh yeah, it's not that hot. We're in Richmond, right? Red means warm. Yellow means hot, white means very, very hot, right? And you see that there's a clear spatial pattern of the temperature in the city. Here you're looking at a map of redlining in the 1930s. And I'll get back to what is redlining in a second. Aidan probably knows already, but the rest doesn't. Now, so these are areas designated in the 1930s. These are the same areas, but now we calculate the average temperature in each of the polygons, right, in each of the areas. And what you see is that the redlined areas tend to be hotter than the others. That is what you see in this graph. In this graph, we're looking at the number of trees that are in the areas per square meter or something like that. We're in America, so that they can do it per square meter, per acre or whatever. And you see that there's fewer trees in the red areas, right? And then here we're looking at impervious surfaces, which is essentially an indicator for flood risk, because if you have a pervious surface, it can soak up the water. If you have an impervious surface, it just starts flooding the area, essentially. And you see again that the flood risk is higher in the red areas, right? So these patterns that we see are not at all random. These two are of course closely correlated because trees provide shade and keep the place cool. This is a separate risk. Now, what is redlining? Redlining is a policy all over the United States, but particularly in the southern United States, and Richmond is sort of the furthest north you can get in the south, was a policy where the local authorities designated certain parts of town as good for economic development. Essentially, the local municipality drew areas and said, in the green areas, yes, you should go invest, you should put a factory there, you should put your shops there, you should start making and selling things there, right? The red areas, they essentially said, don't go there, right? This is a bad economic neighborhood, this is a bad neighborhood, don't invest there, right? That is essentially the difference between the green and the red, and then the yellow and the blue are in between, right? That is redlining. Now, why did they single out certain neighborhoods as a bad economic environment? This was racism pure and simple, right? This is where the former slaves, the black people lived. The green is where the white people lived, right? That is, and of course they did not sort of like say, don't go invest in black neighborhoods. They sort of like drew a nice map, drew circles and areas on a map and said invest here and don't invest there, and they colored them red and green. But it was a racist policy, right? Now that was in the 1930s. Because of how neighborhoods develop and sort of the momentum in neighborhoods, this is now, right? This is almost 100 years later, and we still see the effects of that abhorrent policy 100 years ago, right? So this is environmental justice, right? Certain people get targeted for environmental problems. In this case, being exposed to heat and therefore suffering heat stroke and those sort of things, or being exposed to floods. Previously, it was being exposed to air pollution. Now, why does this happen, right? Essentially, there's two reinforcing, mutually enforcing, reinforcing mechanisms. One is that environmental hazards tend to be sited near the poor and deprived. And the reason for this is essentially that they have less voice, that if the city government needs to plan a waste facility somewhere, where are you going to put it? You can put it on this part of town, you can put it in that part of town. In some parts of town, people are rich and well educated, and they have the telephone numbers of journalists in speed dial, right? Or the telephone numbers of their local politicians on speed dial. So you don't want to go there, because if you try and plan something in an area where social capital is high, where political connections are high, they're going to protest, and they're going to effectively protest, right? If you put your hazardous facility in an area where people are not so well connected, where people do not know how to write an angry letter to the newspaper and get it published, right? That's much easier, right? Because then local protest will be there, people won't like you, but they don't have the capability to organize, right? So if you are a rational politician and you're going to cite something hazardous, you're going to put it in the poor and deprived, poorly connected neighborhood, right? And they tend to be people with a darker skin color, right? In the United States. Then a second thing kicks into place. And when we talked about hedonic pricing, I said, well, if you live in a nice environment, your house becomes more expensive relative to houses near hazardous facilities, right? So if you're going to put these hazardous facilities in a neighborhood, then you're going to suppress the house price in that neighborhood. And that means that the richer people look at this and think, I don't want to live there. And the poorer people think, yeah, it's more hazardous, but at least I can afford a roof over my head, right? So house prices are lower near environmental hazards, then you attract poorer people, less well-educated, less well-connected people into your neighborhood, right? And these two mechanisms reinforce each other. And that is why you see persistent effects in the case of Richmond over a century, right? Right? So that is environmental justice. It's not pretty. It's not pretty at all. Now, in the United States, this is an issue of race, mostly. In other countries, and most of this literature on environmental justice is about the United States. In other countries, it divides along whatever divides people in that country, right? So in the UK, we find similar things, but not nearly as pronounced, right? What you sort of like saw when a lot of people from South Asia moved into the UK, we saw very similar patterns emerge. But now the South Asians essentially have taken over local politics, right, in many of these areas, and they're making sure it doesn't happen again, right? In the United Kingdom, you see these dividing lines now more around class than around skin color, right? If you would to do this analysis in India, you would see these lines divided based on religion and caste, right? Rather than skin color, right? So it depends very much on what country you're looking at. It's always the poor and deprived who get hurt, right? It's not necessarily ethnic or racial lines, right? And it is, of course, a major concern, right? Now, the story doesn't end there, right? If the pressure on the environment is different for different socioeconomic groups, and it is, then also environmental policy will have different effects along different lines, right? So, two maps of London. So this is the Thames. This is the M25. I'm pretty sure that this is the M25. And then in red, you're looking at inner London. Why does it not say what it is? I'm pretty this is traffic, right? So I'm pretty sure that this is something like PM10 or PM2.5 stuff that is generated by traffic. It may be a noise map, but we don't see Heathrow. So I'm pretty sure this is PM10 or PM2.5. PM10 is the bigger one. PM2.5 is the smaller one. So that is the map here. It's a map of environmental pollution, air pollution. And here we're looking at a map of deprivation in London. Yellow, red means dirtier, red means poorer, and again you see a correlation between the two, right? That this form of pollution, whatever it may be, hits the poorest hardest also in London. And then Ken Livingstone introduced this low emission zone in London, and this was a while ago, right? Because Livingstone was the mayor before Boris Johnson was the mayor, so we're talking a good while ago. Now we have a scale. This is the bigger map, this is a smaller map. Maps are the same. What we're looking at, what would happen to nitrogen dioxide, it's bad for you, and PM10, which is also bad for you, but in a different way. What would happen to these two pollutants if we put in this low emission zone in central London, right? And what you see is an improvement, right? This is the difference, and the larger the color, the greater the difference. So not so much of a difference here, but very substantial differences here, a substantial reduction in emissions. And then you can draw these maps, right? So in blue we're looking at PM10, in orange we're looking at nitrogen. I made this graph, right? And the previous graph it was nitrogen dioxide, and now it's dinitrogen oxide. I'm pretty sure that this is the error, that is NO2, not N2O. So this is, if we simply take these two maps and map or chart pollution against deprivation, then this thing happens. And what you see is that the more deprived you are, higher number means greater deprivation, the higher your exposure, particularly to the orange one, which I'm going to call NO2. Right? And then this is the change due to the policy, which we can then also map against deprivation. This is the improvement. Improvement here is measured in years of life gained per 100,000 people, right? And what you see is that, yes, if environmental pollution disproportionately hurts the poor and deprived, then cleaning up the environment disproportionately benefits the poor and deprived, right? So, now, why is Ken here on the phone to Hitler, no doubt? This was Red Ken, right? This was his agenda to help the poor, and he actually succeeded here. He was, of course, much despised after that. So it's complicated, right? Environmental pollution hits the poor the hardest, and they are often people of different religions, often people of different skin color than the majority. But it also benefits the poor the most because they suffer the most, right? Now, two more things I need to say about this. Environmental pollution disproportionately harms the poor, so environmental cleanup disproportionately helps the poor. Should of course not forget, and I've said this a couple of times already, that environmental policy typically makes necessary goods more expensive. A lot of pollution comes out of energy, a lot of pollution comes out of agriculture. These are necessary goods, and therefore environmental policy typically harms the poor, right? So we have these free moving parts going on. So it is a complicated relationship. And then in the remaining 13 minutes, there is also the behavior of the environmental movement. And some of you will not like what I'm going to say. In the very first lecture, I talked about the Enlightenment and the counter movement to the Enlightenment, particularly the technocratic nature of a lot of the Enlightenment, where people said, yeah, but my feelings are important too, and this created this movement called sentimentalism, where essentially you said, well, if I just feel good about a decision, then it's a good decision, right? Sentimentalism grew into Romanticism, where people started essentially idealizing the past, and then Romanticism grew into Naturalism, where people essentially argued three things. One is if you go regularly out for a hike, that's good for your physical health, and that is true, indisputably so. It's probably also good for your mental health, because definitely a long walk sort of clears the mind, right? And there is evidence that indeed people who live in greener environment, people who regularly exercise outdoors, feel better, less depressed, those sort of things. So those things have a good foundation in research, but these naturalists also argued that people who go out regularly enjoy a walk in the forest or on the downs, they are also morally better, which is complete hogwash, right? It doesn't make you a better person if you do these sort of things. So that was naturalism, and then naturalism grew into environmentalism, where it's not just nature, but it's all environmental problems that we care about. But I also said that Romanticism had two other offspring, right? One was communism, and the other was fascism. These siblings of environmentalism sort of occasionally still continue to spill over into environmentalism, right? So in the election before last, the Green Party of Germany sort of in their campaign sang this song Ein schönes Land, right? Which translates as a beautiful country. It's a terrible melody, and they did sing it very badly, but that is not why some people were upset. Because the melody of Ein schönes Land used to be the melody of Kein schöner Land, right? German is a very subtle language. Ein schönes Land means a beautiful country. And I think we can all agree that that is something that we should strive for. Kein schöner Land means no country as beautiful, right? Where the people who sang the original lyrics and the original melody did not just argue that Germany was a beautiful country, which it is, right? Parts of Germany are stunningly beautiful. Not a lot of tourists that go there, but parts of Germany really are stunningly beautiful. But these people argued that no country is as beautiful as Germany, right? So the love for nature became entwined with nationalism, right? My country is better than yours. My people are better than yours, right? And of course, the people who wrote Kein schöner Land, the original lyrics, were the Waldvögel, and they are one of the precursor organizations of the Nazis, right? So the Greens in Germany apparently did not occur to them that you could not pick up the anthem of a Nazi precursor organization and just sing that, right? It just did not occur to them just how bad this looked, right? And these things are still there, right? The Worldwide Fund for Nature, which you may think of as a very respectable organization, and that is definitely how they portray themselves, right? There's many environmental organizations. WWF is sort of the more patrician of them, right? It's more the organization for the upper middle class and the upper class. Greenpeace is more for the plebs. WWF is more for the upper class, right? Now, the Worldwide Fund for Nature was funded by a number of people. One of the founders used to be a Nazi, literally, not in the way we know it now. No, he volunteered and became a member of the Nazis. Another founder was a member of the Afrikaner resistance movement. That is the organization that created apartheid in South Africa, right? And then all other founders were like the Duke of Edinburgh, another famously tolerant of other creeds and other skin colors, right? And the original purpose of the Worldwide Fund for Nature was not to protect nature, but it was to make sure that the hunting grounds for large game in Africa would remain open for the European aristocracy after independence, right? That was their founding, that was the reason that the WWF was founded. They were afraid that if Kenya would become independent, then the new government would kick out the whites who'd like to shoot elephants, right? And they did not like that prospect, and therefore they created the WWF, right? Now, that is a long time ago. You may say, well, this happened in the 50s and the 60s, right? WWF still occasionally cares more about monkeys that live in the forest than the humans that live in the forest, right? Humans that live in the rainforest tend to be a different skin color than the Europeans that fund WWF. Greenpeace does some pretty atrocious things as well. And that, I think, is best seen with this particular example. So, if you don't have enough vitamin A in your diet, you are in trouble, definitely, if you're a young kid, right? And about 250,000 kids suffer from vitamin A deficiency, and 1 in 100 out of 250 million, so that's a lot of kids, right? Dies because of vitamin A deficiency. So this is a lot of dead kids, right? And the other 99 are prone to diseases, all sorts of infections, because vitamin A essentially fights infectious disease, and it helps develop your eyes. So if you don't have enough vitamin A as a child, chances are you'll go blind or see badly. This, of course, RFK, is not a reason to feed everybody as much vitamin A as possible, right? Too much vitamin A is also bad for you. This is a warning for the people who think that if you feed my kid enough vitamin A, I don't need to vaccinate them against measles, right? No, they still get measles, and they probably have other diseases as well. But definitely you should get plenty of vitamin A in your diet. Now, why do kids not get enough vitamin A? Essentially because they don't eat enough vegetables, right? They survive on a diet of mostly rice. This is a problem that's particularly important in Asia. So what people did was they took a gene from carrots, essentially, the beta-carotene, the gene or the thing that makes beta-carotene, and stuck that in rice. Essentially, they took something from carrots and stuck it in rice and created a thing called golden rice, because essentially you also adopt part of the color of the carrot, right? So you have a slightly orange hue in your rice, and that's why it's called golden rice. And if you feed kids golden rice rather than normal rice, you take away their vitamin A deficiency. So you would think, or definitely I would think, that this is a brilliant invention, right? And let's roll it out. Well, I should not do that. Golden rice was invented, commercialized in 2004, extensively tested. Is this safe for the environment? Yes, it is. Is this safe for human consumption? Yes, it is. It was declared safe 14 years later. It is not being used, right? And the reason it is not being used is because Greenpeace, an organization in North America and Western Europe, where no kids suffer from vitamin A deficiency, is sponsoring activists in the Philippines and in Thailand and where have you to go destroy fields of golden rice, right? And lobby the government to not allow this, right? So the preoccupation of white people against genetic modification is killing Asian kids and African kids, right? That is Greenpeace for you. So it is a complicated relationship, right? It's a very complicated relationship. Environmental pollution harms the deprived, but environmental cleanup helps them, right? But environmental policy then again may disproportionately hurt them. So it's complicated enough, and then we have this environmental movement that seems to be preoccupied with some of the things that only the rich and well-connected, paler-skinned people tend to care about, right? Environmental justice is a nice, complicated moral morass.